in this topic. All right, so that's what today is. We had a great review session, period 3. A lot of kids asked questions, and we went right to the review and said, all right, here's what I'm talking about. So I'll let you open it up to you guys. Anything on here? It's been a while since we've done something like that. You're a little shady on. Jake! Clocks. You got it, boss. You tell me what time.
3.
I'm not doing 3 o'clock. That's 90 degrees.
5.
5 o'clock. All right, let's do 5 o'clock. Okay, here's the question. Similar to tomorrow, but it won't be 5 o'clock. What is the angle formed by the hands of the smaller angle? Because I got a smaller, or I could find the larger angle on you tomorrow. Okay, so let's just do the smaller angle formed by the hands of the clock at 5, but I want it in radians. Okay, so what is that angle measure right now at 5 o'clock in radians? The smaller angle. And make sure you're paying attention tomorrow, whether it's the smaller or the larger. All right, so I want the smaller angle formed by the hands at 5 o'clock in radians. In radians, final answer. Forget the radian part. Let's do degrees first, and then we can convert. All right, so let's try to work together here, figure out what's that angle in degrees, and then we can convert it into radians. How are we going to do the degree part? Go all the way around, Aaron, and where are we at?
Wait, what? I was
Go all the way around the clock. Oh, go ahead.
360.
360. You're going to tell me 30 here?
No, I just didn't. I didn't compute.
No, what's your?
360 divided by 12.
Okay.
And then you do times 5.
So 360 all the way around, right? And I got 12 even spots here on the clock. Divided by 12, that gives me what? 30. Now, what's that 30 degrees represent? That means when you go from 10 to 11, you went 30 degrees. If you go from 6 to 7, you went 30 degrees. So I'm going from 12 to 5, though. So how many degrees would that be? 150, right? And if anybody doesn't know where the 150 came from, ready? 30, 60, 90, 120, 150. 30 degrees every time I go 5 minutes. So there it is in degrees. And this is a great problem also to review. How do I turn it into radians? Everyone's going to have a formula sheet tomorrow. It's on the formula sheet. What do I need to multiply 150 by to get into radians? So you look on your formula sheet right now. If you get called on here, I look on the degree part. Look on your formula sheet where it says degrees, because this has been it's probably been about 2 weeks since we did this topic. What do I multiply 150 by to turn it into radians? Oh, let's start today off with number 7. Multiply by. Tim? Multiply by what? 150 by what to get into radians?
Degrees to 1.
What do you got?
Oh, degree.
On your go ahead, take your time. On your formula sheet, degrees to radians.
So it'd be 3 over 5 over 6. 5 pi over 6.
Well, I'm trying to get there though. You're getting ahead of me. What do I need to multiply 150 by to get into radians?
Pi divided by 180.
That's what I'm looking for. Thank you, sir. Pi over 180. We always keep the pi in our answer when we go to radians. And now I just look at the calculator and do 150 over 180, and it'll reduce it for me. And Tim, I think you already did. What was that again?
5 over 6.
5 pi over 6. So that's what that angle is in radians. And all I'm going to ask you tomorrow, read the question, because I am going to specifically say the smaller angle, or I could say the larger angle. So make sure you just be careful and read tomorrow at the time I give you and which angle you're finding, smaller or larger. We good, Jake?
Mm-hmm.
Great question, because none of these are in there's no clock questions in your review. They come up on Delta Math earlier, but none in your review. All right.
I got a question on 2.
Oh, do you?
I do.
This 2 or the 2 in your packet?
The 2 in my packet.
The 2 in your packet. We can talk 2 in your packet.
So it says a
Yep.
flower bed is planted in the shape of an arc.
That's
along
cute. Yep.
The edge, blah blah blah.
Yeah.
If
Bobby.
the circle has a radius of 5 yards,
Yep.
and the angle
That's a big word.
subtended,
There's a little
but
SAT
the
word.
arc measures 1.5 radians.
Yep.
What is the length? So I originally did.
So first of all, this is theta equals
theta
S over R.
equals S over R.
Absolutely. I see a shape of an arc. I see the word arc. I see a circle and a radius. Theta equals S over R. All right, talk to me.
So then, but what I got confused on when I got the problem wrong when I did it on my own, I put 1.5 over.
No.
But
See how it's in radians? There's only
Yeah,
one
makes
thing
sense.
that there's only one thing that can be in radians, and that's an angle. Okay? Only one thing. I can't measure an arc in radians. I can only measure that in centimeters, inches. Same thing with the radius. The only thing, Jared, I can measure in radians is an arc, is an angle.
okay.
So that's got to go.
So even though it says the mark measures 1.5 radians, it's not referring to the arc. It's referring to the theta.
Correct. And yep. Or degrees or radians, always angles. Always angles. Okay? Degrees or radians, always the theta. And now, no need to convert because it's in radians. I'm looking for the radius was 5, so I'm looking for the arc length now. Good deal? Okay, great question. Okay, come on, let's go, kids. Dylan.
I probably know this already, but the graph and angle, what is that referring to?
You got it. Let's go right to a problem. How about number 6, everyone? 6. We're going to get a couple topics done here, including your graph and angle. 6, wakeboarding. Anybody wakeboard? I've never even seen it done, but I guess it's a combo of surfing, skateboarding, snowboarding, and water skiing. Huh? All right. Nobody? Okay. Water ski? Okay. Snowboard? All right. Skateboard? Surf? It's a fun class. Adventurous. I don't blame it. I don't do any of the 4 either. Anything attached to my feet, I look like a big dancing bear. So, yeah, nothing to roller skating, skiing, nothing new. Thank you. That's not going to look pretty. All right. Other than sneakers, that's the only thing that stays on my feet. So, not that anybody cared, but just a little side note. All right, let's draw an angle of 470. Here comes your question, Dylan. Draw an angle of 470. I'm not a big fan of 470. A little too big for me. Anybody want to make it a little smaller?
Minus 360.
Subtract 360 from it. Yep. And that should give me an angle I'm more comfortable with graphing, which is 110. All right, so graph 110 instead. So what quadrant am I in? 110. Oh, 9. What quad? Second quad. Closer to 90 or 180? 90. But when I do my rotation arrow, I'm graphing 470, right? Not 110, 470. So here we go. Starts on the initial side. 470, ready? Past. How many did I just go right now? 360, right? So to end up with 410 or 470, I just go to the I don't go around again, because you go around a second time, that's 720 degrees. That's all I need right there. So Dylan, that's what I mean by graphing an angle. Let's keep going though, so I can hit some other topics. Determine the smallest positive coterminal. We just went over coterminal with reviewing your quiz. That's add and subtract 360. I hate to break it to you, but we already answered this question. The smallest positive, which would be 110, yeah. I don't want to subtract 360 again because I'll get a negative answer. So coterminal, add, subtract 360. And then part C, what about the reference angle? Again, I would not use 470. I'd use that 110 we just graphed. Remember your reference angle? X-axis and the terminal side. So here is your reference angle. How do I find it? Go ahead, Nick.
You take the line, the quadrant line on the bottom, and you subtract that from your answer.
Which, so what do I got here? 180 minus.
110.
Yep.
You get 70.
Before I move on, anytime you're asked for a reference angle, it should follow what two rules?
The x-axis.
Positive.
It's got to be on the x-axis. Yep. It's got to be
Less than 90.
positive and acute, less than 90. Always. Anytime you're going to leave a reference angle as an answer, it's got to be positive and it's got to be less than 90. We're all good? Yeah. What's your deal?
Could it be 90 or no?
No.
No.
Nope. It's got to be between 0 and 90. Okay? Got to be between 0 and 90. Anything else? Good question. Going? All right. Hey, let's go back. Keep on. Come on. Ask away here. This is what the review is for today. Aaron, let's go. Okay, Pythagorean theorem. Go to question number 3. You guys this is great. Asking the same questions as last period. And plus, I did need to mention number 3 because it says find all the missing sides and angles of RST. And is there like a magic ink here I'm supposed to do? Put the black light on so I could see it. It's not there. So I need to give you triangle RST. Angle T is the right angle. And here's S and R. And here I'll give you 2 side lengths. TR is a length of 20, and SR is a length of 10 radical 5. So our job on this problem, find all the missing sides and angles. Okay, all the missing sides and angles. Well, it's only missing one side, so let's start with that. How do I find the missing side here? What type of triangle is it?
Right triangle.
It's a right triangle, and I already know 2 sides, and I'm trying to find the third. So this is automatic Pythagorean theorem. Yep, when you already know 2 sides of a right triangle, and I'm trying to find the third, Pythag. All right, let's do it. What are the 2 legs here? 2 legs for A and B in this diagram. The 2 legs are, 3.
A squared is 1 squared.
Okay, yep. So can I put X? Is that right?
Yeah.
The missing side here, X squared and 20 squared, making the C, the hypotenuse, 10 radical 5 squared. All right, I think this is probably where we go to the calculators, right? X squared plus 20 squared, 400. All right, be careful. Hey, little calculator tip. Be careful when you do 10 radical 5 squared. If you just type in the calculator like this, calculators think you just want to square what?
Radical 5.
Yeah, you don't want to square radical 5, right? You want to square the whole thing, so make sure that thing's in parentheses when you square it. Because if not, your calculator is just going to think, oh, square the radical 5 and I'm good. 500. Yeah, 500. Next move.
Subtract 400.
Subtract 400. That's a nice number, right? X squared equals 100, so X equals 10. There you go. So there's my third side, 10, using Pythag. Everyone okay? Not going fast. Next part, what about one of the angles? Because I got to figure out both angles. So your call. Do you want to go angle R or angle S? Your call. 8, your call. R or S? All right, R it is. So we got to find angle R. This is what we did yesterday. Sine, cosine, tangent to find the angle. There's no other way I'm finding the angle. Bless you. Now, could I plug 10 in here and use 10 as a side? Sure. I'm going to leave it out so it's not confusing. I'm just going to use the 2 sides we originally had. But yes, you could plug the 10 in and do opposite. That's fine. What are the 20 and the 10 radical 5? What sides are those from yesterday's discussion? Here's angle R. What's the 20 and what's 10 radical 5? Opposite, adjacent, hypotenuse. 7, what's the 20?
20.
Yep. with angle R? Is that opposite, adjacent, or hypotenuse with angle R? The 20, Tim.
Adjacent.
Adjacent, good. And what about the 10 radical 5 I had down here?
Hypotenuse.
That's the hypotenuse. Great job. Again, you want to use the 10 we just found? Fine. That's up, but only use two sides. Don't use all three, just use two. All right, so if I have adjacent and hypotenuse, which one of the three can I use tomorrow? 6, if I have adjacent hypotenuse. The what?
There's cosine.
Cosine. Have some self-respect. Cosine. Yes, cosine. Of what angle? Right, because usually put cosine of the angle.
But it's X. So.
X, right? X. Or you can put R if you want to. Can I put R? Is everyone all right? You don't freak out if I put R. You can put X. Equals. What? How do I put these sides over each other now? 1.
You do
What was after the C in SOHCAHTOA?
20,
Yep. So what's the adjacent side?
20,
Over.
10 radical 5.
There you go. Discipline. Be disciplined. This is, hey, I'm fine. What am I finding? An angle or a side? Angle. So there's none of this and cross multiply. Right? Only for a side I cross multiply. What are you going to chime in with there, tough guy?
The -1.
Yes. If I'm finding an angle, I do the inverse cosine. 20 over 10 radical 5. Yep. You only cross multiply when finding a side. If you find an angle, I do the inverse. So go ahead and make sure, if you weren't here yesterday, make sure your calculator's in degree mode. If you're using a new calculator, make sure it's in degree mode. Make sure you're in what, though? Yeah, darn right. Only one mode tomorrow. Yeah. Wait, you think this is bad? Wait till the readings exam. I just go off.
Do you lose your voice?
No, no. It probably could happen, but. What do you got? Nearest 10th. What's this angle? 27. Oh, it says to the nearest degree. Sorry. Yep. So 27 degrees. Good. Almost done. We got one more angle. All right, look. Can you save me some time? I don't want to have to do sine, cosine, tangent again. Is there a way I could get to angle S a little bit quicker? What? What's your what? Go ahead, Tim.
By adding to 180, but adding 90 plus 27 plus question mark.
Question mark. That's what I get on a lot of your papers.
Or
Oh,
equals
too soon? Too harsh? Sorry. Too harsh? Yes. Everyone see what Tim's saying? 180. Remember your geometry days? 180 degrees in a triangle. So why am I going to do sine, cosine, tangent and waste my time and maybe get it wrong? Hey, I got 180. Angle was 90. Just found the other was 27. Angle S, 63 degrees. All right. And I think this is a nice time for me to stop and for you guys to work. You already have Classroom open, right? Perfect. Open up the homework answers, please, so you can see the review answers here. Open up the homework answers. You guys see day 3.8. Open them up and let's get rolling. You want to work with other people, move around. If not, let's get grinding. Oh, sorry. One last thing. Go to question number. There's something on one of these questions you've never seen before, and I want to make sure you're good. Question 9. Question 9, please. It talks about a right triangle. It tells you angle C is 90, but we've never seen this, lowercase b and lowercase c. Those are the sides across from those angles. Got me? So lowercase b means the side across from angle B is 15. That's what those lowercase letters mean. All good? Those are the sides across from those angles. You good there, boss? You want me to draw it?
Yeah.
Okay, here you go. Here you go. Here's C, A, and B, right? The side across from angle B is 15. The side across from angle C is 22. And then you have to find angle A. All right?
Is there gonna be like one like that?
No, will not be. It'll be clearly, I'll call it AC and AB instead. All right? Come on, let's go. You just got to come in here hungry tomorrow. Hungry.